For joining us today. Today we'll be discussing lazy functional programming. My name is Ron Nathaniel, and let's jump right into it. And so to start off, we'll discuss just the beginnings and the differences between imperative and functional programmings. Imperative programming is usually referred to as top-down. What that means is, let's say I have three operations, X, Y, and Z. First, I'll tell the computer to do X, the computer will do X, and then I'll say, computer now do Y, computer will do Y, and so on. It's very rudimentary, it's very one step at a time, and it's very short-sighted. It'll only do what's immediately in front of it, and without considering the future and the outcomes of what it's doing. And functional programming is a bit different, in that, let's say I have three operations, X, Y, and Z. The computer will take one scan down the file. It'll say, okay, you have now three different operations, X, Y, and Z. It'll work its way back up the file after having recognized everything that the file is now doing, and it'll replace my three functions with one monolithic function, which in turn will call my three XYZ functions. And so what that does is the computer kind of makes sense of exactly what I built out for it. It'll replace it and put its own work instead, just for simplification, and then it'll work top down. And that's this little arrow on the inside. And so that's very important to realize. How imperative has just this one big arrow down, it's working from the top down. Here, there's a bit of preparation beforehand, and only then it's able to work its way top down. And so let me show you what I mean. And what I'll be proving to you today is how lazy is better than eager, in my opinion. And I'll be showing you exactly what that means, and what lazy means and what eager means. And so to begin, let's start off with this function, with this just little strip of code at the very beginning. And this is pseudocode, I might point out. This is not real code. This will not work in any language. I used a bit pieces from modern languages today, which happen to also be imperative, but that's besides the point. And so what it is we're declaring a function at the top, and then we have our conditional check, and if it happens to come out true, then invoke this operation at the bottom. And so now let's get into the nitty-gritty of what it means between eager and lazy. Eager will do this. It'll define the function and recognize that I have a function call inside of the conditional. It'll take the function call and throw it outside of the conditional to be done beforehand. After having saved the result of that, it'll take that result and put it inside the conditional. And then it's able to do with that result whatever it wants later on, without having to recall foo several more times later on. And what this results in is having done foo before the conditional. And this is important to note. Versus its counterpart on the lazy side, on the right hand side over here. And how it'll show that this function definition won't change. It'll still define foo, but it recognizes that the first term inside the conditional is false, and it's bounded by an and. And this is just an example, but this is really how it works. It'll recognize that this condition will never be true. And for this reason, as the computer is reading this code from left to right, it'll get to false, and when it hits and, it'll leave. It'll leave that condition, and it will never even read this. And so lazy functional programming is smart enough to, on the first roll down the file, it'll recognize that foo will never be called. And so it'll manually go in and change the computer code to remove that from the conditional. It'll say if else, and nothing more is needed because it will never evaluate a true. And so this code will never run. And so in turn, foo is never called actually in lazy programming. Right? And it's very important to note that foo was never called in this example. Right? And this is just an example, but this is really how it works in real life. And so I know what you may say, oh, it's so lazy, it's not trying to do as much work, but that's not entirely true. It's lazy by nature, but it's always a hard worker. It does what I call the homework beforehand, in that in the first roll down the file, it'll try to fill out exactly what it's doing, and it'll check for all calls of a specific function, all past and future references to a variable, and all conditional branching, as we saw in the slide beforehand with the if statement. And so I like to call lazy actually the homework doer. And the analogy with the homework that I'm giving here is that it does its homework before it gets to class. So by the time it gets to class, aka running your code, it'll already have done its homework and already knows exactly what it's walking into without any blind surprises. And so the perfect analogy for this, I would believe, is that lazy functional programming is like a sloth. And that sloths don't like to move. They move very slowly and they don't move a lot. But when they do move, they're very strong. And on average, a sloth is 3 times stronger than the male human, on average. Did you know that one sloth arm can carry 3 times its body weight? So just like functional programming, don't judge it by a first look and actually take a look under the hood to see what it's really capable of. And so what I like to call lazy is lazy when it can, but strong when it needs. And so you really get the best of both worlds with lazy functional programming. How it's lazy in some senses that it doesn't like to do extra work, but because of this, it's very strong in realizing that it doesn't need to do this extra work. Below listed are my works cited, and thank you very much for joining us today. I hope you agree with me, and I hope I was able to get the message across.